How you doing, class? Yesterday you got this second essential assignment, and I wanted to talk about what I think is maybe the most difficult part. It's a math we've discussed before, but it's been during this whole shutdown thing, so some of you may have missed some of those videos or whatever, but I wanted to go over this formula one more time and talk about how we could graph something like this, how we could find the maximum value, because it's what you need to do for this project, and how you could go about analyzing the whole thing. And we're going to get started on that today, and we'll finish this problem tomorrow. I'll actually leave it for you and see how much you can do, and then you can check it tomorrow. But here is the equation, similar to the equation you have in the project. It's going to be a parabola that opens downward. And I'm going to do this by graphing or just setting up an XY table. So like we've done in the past. And I'm going to divide this table up into 5 pieces. If you have more, that's better, especially for when you want to figure out where it touches the x-axis. But we'll get to that later. So right now we're going to look for 5 pieces, and this middle piece here is going to be the vertex. So I'm going to look for that point first, the vertex. And how do I look for that point? There's a formula we learned. The formula was negative b over 2a. So this is a, negative 1/3, b is 10, and c is negative 20. We don't need c for this formula. This is going to give us the x value of our vertex. That's what that formula is going to give us. So I'm going to replace b with 10 and a with negative 1/3 and see what happens. So that looks ugly with all the fractions. It's like a fraction within a fraction, but we can simplify it. 2 times negative 1/3 is negative 2/3, and if I do a negative divided by a negative, it's always positive, right? So I can rewrite this like this. Positive 10 divided by positive 2/3 instead of negative 10 divided by negative 2/3. And then you're dividing 2 fractions. That's the same as 10 over 1 divided by 2/3. Same thing. But when you divide 2 fractions, you multiply the first fraction times the reciprocal of the second fraction. Some of your teachers taught you keep, change, flip. So times 3/2. When I do that, I notice that this 10 and this 2 cancel, and I end up with 5 times 3 for my final answer. So all that work to get the x value of the vertex, that's going to go right there. 5. So we've got the x value of the vertex. Now we need to find the y value. Well, I'm going to use this function up here. I'm going to rewrite it as f of x. Same thing. And if I want to find the y value of the vertex, I just replace x with 5. So I'm going to find f of 5. Everywhere where I see an x, I put a 5. And I need to calculate that. I messed up. That's a 15 here, huh? So this should be a 15. So this should be a 15. So that should be a 15. There, now it's correct. So now I've got to calculate that. Well, 15 squared is 225. 10 times 15 is 150. 1/3 times 225 comes out to be 75. So I have got negative 75 plus 150 minus 20. All of that is equal to 55. So now I know my vertex. What am I going to do next? Well, what I do next is I need to pick some points to the left of the vertex and to the right. And for this problem, because I'm multiplying by a negative 1/3 in the beginning, right up here, that means I'm going to always be multiplying that by negative 1/3, and it's the same as dividing by 3. So if I pick x values that are divisible by 3, this will be a lot easier. So here it's 15, that works out, and I get a whole number. If I go by 3's to find my other values, it'll just come out with all whole numbers. It'd be nicer. So I'm going to go 15, the next one will be 18, then the next one will be 21. If I kept going, it would be 24. Back here, I'll put a 12 and a 9. So now I've got everything going by 3's, and to get a graph of this, to finish off this table, I need to find out what is f of 9. And then I need to find out what is f of 12. Just replacing the x values with 9, and then replacing the x values with 12. When I do that, those answers, whatever they are, will go here. Once you know that, you could also find f of 18, and you could find f of 21, but you don't have to. If you did this work correctly, what ends up happening is it's a parabola, right? And if you are on the vertex here, that's the maximum point. So this is the maximum height right here, the 55. And whatever f of 9 and f of 12 is, they repeat. So it's going to go up, it's going to increase to 55, but then it's going to go back down after that point, because that's the maximum. So whatever f of 12 is, that also goes here. I'm going to write it like this. F of 18, obviously, but that is also the same as f of 12, so you don't really need to calculate it again. This would be f of 21, but it's going to go back down to whatever f of 9 is. They're the same. So, your job to finish this problem is to find f of 9, find f of 12, just substitute, oops, that was supposed to be a 15 too. Substitute, instead of x, put 9. And then instead of x, put 12. Find those answers. Those answers go here and here, but they also go here and here because of the way a parabola works. Then you'll have 5 points to graph on your parabola. The middle point will be the highest, your maximum height. You can keep graphing if you want. You can keep finding ones until you get down to the zeros, and then you can calculate how far it goes. All kinds of things you can do. We can finish talking about that tomorrow, but I'll let you actually try before I do it, and then tomorrow you can see if you're doing it right. Okay? Have a good day, everybody.